Hey guys, Mr. G here coming at you again with yet another math lesson, taking a look at those fantastic fractions. Today, we're really going to take another look at how these fractions have the values that we've been talking about. These parts, these wholes, these parts of, and the parts that make that whole. Really understanding the value is going to really help us as we move forward with the unit. And if you haven't already, I'm sure things have been super difficult for you if you haven't had that understanding just yet. Hopefully, we'll get to that how today and in the next few lessons. We're going to do this a number of ways to get a real understanding of the true value of a fraction. And as we know, every learner learns differently, whether it's visually, whether it's using our hands, whether it's writing things down. Everyone learns differently. So we're really going to focus on those do's today, that I do and that we do, and of course that you do as we always. Because if you know how to do, you can do the how of today's lesson and continue mastery of understanding the value of fractions. Wow, that sounded a lot like Yoda.
We don't have the Yoda animation.
May the force be with you for today's lesson. So, enough funny business. For today's lesson, shockingly, once again, you will need a piece of paper and a writing utensil, preferably a pencil. Why? Because got that eraser to fix your work with all that partitioning you may be doing today. Today's learning targets, really focusing once again, as I mentioned, on those do's, how you're showing me the value of these fractions. That's where the learning comes in. And we're going to do that in a number of ways. So, without further ado, our learning target, I can show the value of a fraction using 1, the length model, and showing it as a fraction, or taking that fraction and showing it as a length model. 2, showing a fraction as an area model, taking an area model and showing it as a fraction, or taking a fraction and showing it as an area model. 3, decomposing those fractions once again, taking a look at decomposition of a fraction, so starting with a decomposition expression, and then figuring out what that fraction is, or taking that fraction and then decomposing that into its parts. And lastly, number 4, what we'll be continuing working on is making a whole or zero starting with a fraction. All right, young Padawans, so today I hope I can use my force to help you learn and build a better understanding of fractions and their value. All right, guys, as always, starting off with that I do. During the I do, you're focusing on my instruction, okay? No distractions. Don't follow into the steps of the dark side. Stay away from those Sith and all those hooligans that make those kinds of decisions, okay? Find a space that is comfortable where you can focus on my instruction and just that. Starting off with that I do with the length model. All right, starting with a fraction and showing it as a length model, demonstrating my understanding of the value of fractions using that length model. Guys, over and over and over again, I say it all starts with the parts that make that whole. What is the whole we're talking about? When I do that, always got to look at that denominator. How many parts make the whole in 2/6? That, of course, would be 6. We are talking about sixths. 6 parts make the whole in 2/6. So I create my length model Boom. Okay, I know the beginning of my length model is nothing. It's 0. And I know the end of my length model is going to be 1 whole. So, next thing I need to do, I need to show this fraction. I'm going to partition these two parts, my numerator, the parts of this fraction. I have 2/6 that I need to partition and show on this length model. So, first off, you need to make those 6 parts, 6 equal parts, because we're talking about fractions. A good strategy to use, guys, is always starting in the middle. Okay, so if I'm working with 6 parts, okay, I know that I'm going to have 6. All even numbers are going to have an exact half, an exact middle. I know half of 6 is 3. 3 plus 3 is 6. So, I'm going to partition first. 3 equal parts to make a half. 1, 2, 3. And then another 3 equal parts to make that whole. 1, 2, 3. So, I've made my parts of the whole, 6. I now need to show what those 2 parts of are. We're talking about 2. 1, 2. 1, 2. But we're not talking about whole numbers. We're not talking about 1 and 2. We are talking about 1/6, 2/6. Bingo. On our length model, 2/6 would be represented. Bingo. Right there. We are talking less than 1. We're talking about fractions, 2/6. What I really want you guys to notice, especially when we're looking at these models, when I'm building these fractions, when I'm showing these fractions using any of the models we're talking about, any of the 4 models that I'm trying to help you learn with, we all learn differently as mentioned at the beginning of this lesson, that the denominators don't change. The wholes do not change. The parts that make the whole do not change when we are showing these fractions. I know the whole, when I'm talking about sixths, would be 6/6. 1, 2, 3, 4, 5, 6. 6/6 would be the whole that we're talking about. Our denominators are parts that make the whole, therefore can never change. All right, guys, continuing that I do for the length model. Now we have a length model here. I need to show my understanding of what that fraction is being represented on the length model. So I have this length model partitioned into equal parts, and then I have a circled spot where that fraction would be. So I'm going to have to really understand the value of what this is on the length model. Where do I start? As I mentioned, and I'll continue mentioning, we always need to understand the parts that make that whole. That's the start to every fraction. So I know when I'm looking at a length model, the values are, I have a 0 that starts, and I have that 1. Fractions are equal parts that are less than a whole, that are less than 1. So what I really need to do is figure out what equal parts we're talking about that make that whole. I need to find that denominator, the parts that make the whole. So let's find out how many partitioned equal parts this is. 1, 2, 3, 4. There are 4 equal parts that make up this whole. We're talking about fourths. 4 in the denominator, we're talking about fourths. But how many parts? How many fourths? How many parts of that whole is this length model representing with that circled, with that little spot circled in blue? We need to find that numerator. So, how many parts of fourths? I'm going to jump 1, 2, 1, 2. But am I talking about 1 and 2? No, I am talking about 1 and 2 parts. 1 and 2, 1, 2 quarters. 1 quarter, 2 quarter, 1 fourth, and our answer, 2 fourths. This length model represents 2 fourths. 1, 2, 2 fourths. 4 parts, 1, 2, 3, 4, make this whole. Continuing on with that I do. Now looking at that area model. Taking a look at taking a fraction and showing it as an area model. Taking baby steps, different ways to understanding the value of a fraction. 7/8, making it into an area model. Mr. G, where do we start? Well, fractions always start with the parts that make that whole. So, using that area model, I'm going to start off making that square. This, so far, is my whole. This would be 1 part to make the whole. Just like in the last lesson with that square sticky note. But when we're talking about 7/8, 7 over 8, I have a 7 in the numerator, an 8 in the denominator. The parts that make the whole are 8. I need to partition this whole into 8 equal parts. 8 equal parts make this whole when I'm talking about 7/8. So, a number of ways I can do that. But Mr. G is a teacher. He knows that if he wants his students to have a good visual, he can break that thing in half, and he knows that 2 times 4 equals 8. Just like when we're working with those area models, when we're multiplying. Kind of familiar there. So, if I were to break this whole into 2 parts, and then break it again 4 times, 4 equal times, I would have 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. 8 eighths make this whole. I have the parts that make the whole. What parts are we showing? What is the value of 7/8? What are the parts in this 7/8? The parts of this fraction. I need to look at that numerator. How many eighths? How many eighths do I need to show? I need to show 7. 1 equal part, 2 equal parts, 3 equal parts, 4 equal parts, 5 equal parts, 6 equal parts, 7 equal parts. 7 equal parts of eighths. Look at that. Only 1 more eighth would make my whole, which would be 8 eighths. Taking a fraction, showing it using an area model, getting better at understanding the value of a fraction. Continue to take a look at that area model, but showing that as a fraction. So, looks like I got a pretty little area model right here. Perfectly done, as you can see. I'm not sure who quite may have made that. So, demonstrating this as a fraction. Where to start? Well, fractions always start with understanding the whole and the parts that make the whole. I know when I'm looking at an area model or a whole, I'm taking a look at what's inside because I know fractions are parts that make a whole and that they're less than a whole or they're less than 1. So I need to first find my denominator. What parts make that whole? So I can see here that this whole is partitioned into equal parts. How many make the whole? 1, 2, 3, 4, 5, 6. It looks like this area model has 6 equal parts that make the whole. It is sixths. It is broken into sixths. So the next question is, how many parts are of this whole? We know it's not 6, even though we're talking about sixths, that would make the whole. But what parts of the whole are shown here? What is the value? Well, I can see that 1, 2, 3 parts are shown that have that value. Notice that the parts don't all have to line up like all the other area models are. Why is that? It's because we're talking about equal parts, guys. But there is a number, there is a quantity. 1, 2, 3. There is 3 parts of 6 sixths that make the whole, but there's 3 equal parts of that. This area model represents 3 sixths. 6 parts make the whole with 3 parts of. This area model shows 3 sixths. We are halfway through this I do, and I am almost sweating through this shirt. In Mr. G's remote classroom, it is a sauna. Hopefully this thing is not drenched by the end of this lesson. Next I do, taking a look at decomposing those fractions. All right, understanding the value of fractions using decomposition or decomposing. Starting with a fraction and decomposing. My fraction, 5/8. I have a 5 in my numerator and an 8 in my denominator. I have 8 parts, 8 equal parts that make my whole. We're talking about 5 of them. 8 parts would make the whole, but we're talking about less than a whole. Decomposing. The one thing I need to understand is that my denominators never change when I'm talking about fractions. But to help me decompose, I can first start with that numerator. What is those parts made of? What is 5 parts made of? When I'm splitting up a regular 5, a whole number 5, I know that it's broken up into 5 ones, which are wholes, but it is indeed broken up into 5 ones. 1 plus 1 plus 1 plus 1 plus 1 equals 5. It's very similar to a fraction. These are 5 wholes, 5 ones, but we're not talking about 5 wholes or 5 ones. We're talking about 5/8. So when I'm decomposing this 5/8, I know that there's 5 parts. 1, 2, 3, 4, 5. And each have an 8th in them. Each are an 8th. There are 1 parts, and 8 of these parts would make a whole. So I took this 5/8 and I decomposed it into all its little parts. Let's count the eighths together. 1/8 plus 2/8, 1/8. Let's count them together, Let's not add them together, let's count them together. 1/8, 2/8, 3/8, 4/8, 5/8. 5/8 are the parts of this whole, which is 8 equal parts. 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 would equal, or does equal, 5/8. 5/8 decomposed is 5/1/8. A bit confused? Well, guess what? The force is strong with Mr. G. Let's take a look at it with a little visual. Here's my trusty magnet. I'll get it right one time, guys. As always, when we're talking fractions, we start with that whole. I have one whole right here. Boom. Are we talking about one whole, guys? We are not. We're talking about a fraction. What are we talking about? We're talking about 5/8. Right here, I have some eighths. I know if I'm talking about a whole, 8/8, 8 equal parts make that whole. Let's find out. Right now I have 1, 2, 3, 4 eighths. 5/8, 6/8, 7/8, 8/8. 8/8 make a whole. 1, 2, 3, 4, 5, 6, 7, 8. It is equal. But we're not talking about a whole. We're not talking about 8/8. We're talking about 5 parts of 8/8. So let's get back to 5. 1, 2, 3, 4, 5. There's our 5/8. It is less than a whole. Now let's decompose it. Let's take all these eighths apart. All these partitioned eighths we can decompose into each individual part. Not that makes the whole, but that makes the 5/8. That 5/8 we had, okay, just can be decomposed into its 5 parts. Just like 1 plus 1 plus 1 plus 1 plus 1 equals 5 wholes, 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 5/8. 5/8 decomposed with numbers, and for your visual Padawans, the magnets. All right, guys, now taking a decomposition expression, understanding it to show a fraction. So I have all these fractions in an expression. 1/4 plus 1/4 plus 1/4 equals what fraction? Or 1/4 plus 1/4 plus 1/4 equals what fraction? As always, I need to understand what parts make that whole. So I need to look at that denominator. The denominators don't change when we're talking about fractions. In fact, they can't change. We need to understand that there are equal parts. 4 parts make the whole with whatever fraction we're talking about here. I have a 4 in my denominator. But What parts of those 4 parts that make that whole is the question. Well, in this expression, I see 1, 2, 3. I see 3 quarters. So, just like I was going to decompose 3 I know is 1, 2, 3 ones. 3 ones equal 3. So, when I'm talking about fractions, it's the same thing, even though we're talking with parts. And parts that make that whole. 4 parts make that whole. We're talking about 3 parts of that whole. 3/4. 1/4 plus 1/4 plus 1/4 is 3/4. Our parts that make the whole do not change, but the parts we do have can change. Decomposition expression, showing it as a fraction. All right, guys, perhaps the best way, maybe, of understanding the value of a fraction, I do, making 0 or a whole. Making a 0 or whole. Let's take a look. I have an expression here trying to make a whole. 2/4, 2/4. Plus what fraction, how many more parts will make a whole? So when I'm making 0 or I'm making a whole, it may be a good strategy to use other strategies we're using to understand the value of a fraction, such as the area model or length model. So 2/4 plus what fraction is going to equal 1? Well, I know the fraction always got to start with that whole, which we're trying to make anyways. Taking a look at my length model, I have this length model partitioned into 1, 2, 3, 4 equal parts because I know I'm working with fourths. 2/4 would be 1, 2. Right here would be 2/4. Wow, 2/4? That looks like a half. Interesting. So I know I need to get to a whole. It looks like I have 1, 2 more equal parts to make a whole. But I'm not talking about what equal parts am I talking about. I'm talking about 2/4. So I need to add 2/4 to make that whole. Our whole is 4/4. It's really important that we understand that. It's not only a 1, but, or 1 whole, 4 equal parts of 4/4 that make the whole equal a whole. Same thing if we're looking at the area model. We're talking 2/4, 1, 2. How many fourths do I need more to make a whole? Well, I see that I have 2 shaded that are representing 2/4. I need 1, 2. I need 2/4 more to make the whole. Lastly, looking at it just with the expression. To start, when I'm thinking with a whole, I need to know that 4/4 equal a whole. So when I'm looking at my expression, I know I'm working with a fraction. I know I'm working with fourths. I'm really trying to think 2 plus what? 2 parts plus how many more parts is going to equal 4? Well, I know 2 plus 2 would equal 4. 2 plus 2 more, 2, 3, 4. 2 plus 2 more would equal 4. So, that can be represented in my numerators, guys. 2 plus 2 equals 4. But look, our denominators don't change because they can't. We need to talk about the same parts that make that whole. Making a whole, starting with 2/4, adding 2/4 more will make that whole. All right, now let's make 0, helping us understand the value of a fraction. Our expression to make 0, 5/6 minus what fraction will give us 0. Again, it may be a good strategy to use the length model or the area model to help you if the math just isn't all there, which is completely fine. Everybody learns differently. Guys, it all starts with the parts that make a whole. I know I'm working with 6 parts that make that whole. When I'm making that length model, I need 1, 2, 3, 4, 5, 6 equal parts to make that whole. Okay? I know my zero's over here. This is where nothing is. That's where I'm trying to get. I got a whole, well, not a very good whole, not a very good one, right here at the end of my length model. So, I have my denominator here. I know I'm working with 6 parts to make the whole. What? Parts of. I know I'm working with 5. Modeling that on the length model, I would need to count 5 parts. 1, 2, 3, 4, 5. 5 parts. But, parts of what? Parts of 6 parts that make the whole. 5/6 would be right here. So, how would I need to make that 0? Well, I know I'm subtracting, so I'm going this away. Guys, how do I get from 5 to 0? When I'm subtracting, I know numbers get smaller and it's like counting backwards. So, let's see how many it takes to get to 0. Ready? Starting with 5. 1, 2, 3, 4, 5. 5 minus 5 will equal 0. Just like saying 5 minus 5 without our fingers would equal 0. I have 5, I take away 5, I'm going to get 0. So, showing that on our length model, I would take 5 away, but not 5 wholes. We're not talking about 5 ones. We're talking about 5/6. I would need to take 5/6 away. Let's take a look at it with the area model as well. I know I have 5/6, 6 parts make that whole. I have the array, 1, 2, 3, 4, 5, 6 parts make that whole. Only talking about 5 of them. 3, 4, 5. We know it's less than 1. One more 5 would give us a whole, but we're looking for 0. We want to look as if there was nothing there. So, let's subtract to get nothing. 1, 2, 3, 4, and 5. We just subtracted 5/6. Looking at it on the area model, done. Lastly, using mental math strategies or taking a look at the numbers, we can also take a look at it by understanding parts. I know I have 5 parts, and I know that my denominators will not change. So, if I have nothing, I have no 6. I have 0/6. I don't have any parts. There may be 6 parts that make the whole, but we're not even working with a whole. we're working with nothing. So nothing represented a fraction is when we have that 0 as our numerator. No parts. I could have 0 a bajillion. Still 0 bajillions. Okay? So, I have 5, 6. I know that 5 minus 5 would get me 0. But I know fractions, the parts that make the whole don't change. 5, 6 minus 5, 6 is going to give me 0, 6. That's 0. All right, guys, we're going to make this redo short. We are not going to be showing our models both ways, going from a length model to a fraction, fraction to a length model. We are just going to focus on going from our model to a fraction. I'm melting away here. All right, taking that fraction, make it into a length model. Where do we start, guys? Got to start with the parts that make that whole. Got to focus on that denominator. So, work with me here. Pause the video if you need to. Let's make that length model. I know I'm starting at 0 and I'm going to a whole. Okay? Starting at 0, I'm going to a whole. I need to partition my length model into 8 equal parts. Hint, when I am partitioning numbers, partitioning denominators, parts that make the whole, even numbers will always have half. Boop. Well, my half mark is right there. If I were to have 8 on a model, I know that 4 would be in the middle. So I can have 2 parts, 3 parts. Everyone makes mistakes, guys. In between 1, 2, 3, 4, 5, 6, 7, 8. I just partitioned this length model into 8 equal parts. Make my length model look like yours. Pause the video if you need to. We just took our first step. We partitioned 8 equal parts to make this whole, which would of course be 8 eighths. But how many parts are we talking about, guys? How many eighths are being represented? What is the value of these eighths? We're not talking about a whole. We're talking about a fraction. We're talking about 2 parts of 8 parts that make a whole. We're talking about 2 eighths. So, we know that each one of these partitions, these lines, are an eighth. How many more eighths do I need? If I have 1/8, I need to make how many more eighths? 1 more eighth. So, 2 eighths on a length model, I would need 1, 2. I would represent on my length model 2 eighths right there. 1, 2. I know 1 plus 1 equals 2. I also know that 1/8 plus 1/8 equals 2 eighths, which is what I'm looking for. 1/8, 2 eighths. Bingo. Fraction, making it a length model. We do for taking a fraction, showing it as an area model, taking each and every step towards understanding the value of a fraction. Where do we start? We start with the parts that make the whole. We're using an area model. With me, let's make a whole. I'm going to make my area model kind of like a rectangle. You can make yours like a rectangle or like a square. Don't make your rectangle look like mine. Make it neat. So we have a hole there. That would be 1, 1. We have one part that makes 1. But that's not the fraction we're looking to make. We need to make this hole into 3 equal parts. So to do that, I know my zeros here. Well, I'm not working with length model. Sorry, Mr. G. I know I need to make this into 3. So I'm going to make 1 equal part, 2 equal parts, 1, 2, 3. Guys, that's why we have the eraser. If it doesn't look like equal parts, if it doesn't count up to be 3 equal parts, erase and try again. That's how you learn how to partition. Okay? So I made my parts to make this hole. This hole now has 1, 2, 3 equal parts. But how many parts are being represented in 2/3? What parts of 3 parts that make the whole? Gotta look at that numerator. 2. Let's count by fractions. 1/3. What would the next one be? 2/3. Much like 1 plus 1 equals 2, 1/3 plus another third would equal 2/3. 1 2/3. 2/3 on an area model. There it is. All right, guys. We do for taking a fraction and decomposing it or making it into a decomposition expression. So, as we start with all our strategies, you need to start with the parts that make the whole. I need to look at my denominator. I have 4 parts that make my whole. How many parts? 3. The first thing is what, guys? What do we need to know about those denominators? We need to know that they do not change. I can have a bunch of fourths, but they all need to stay that way. So we know we're working with fourths, but how many parts? How many parts to make that whole? We're talking about 3/4. If I were to decompose this number, this fraction, excuse me, I would have 1, another 1, and another 1. I know 1 plus 1 plus 1 equals what? 3. Equals 3. So, but we're not talking about ones. We're not talking about wholes. We're talking about fourths. A fourth plus a fourth plus a fourth would equal 3/4. There is our decomposition expression right there. Let's take a look at what that would look like visually very, very quickly. I know 4 parts would make this. It would make this whole. But how many parts are represented when we know it's going to be less than a whole? We're only talking about 3. 1, 2, 3 parts. But the parts are fourths. The parts are of 4 parts that make the whole. 1/4 plus 1/4 plus 1/4 equals 3/4. We do taking a fraction, making it into a decomposition expression. All right, guys, we do for taking a fraction and making it a whole. Let's look at our expression. Write it down. 2/6, 2/6 plus what will equal 1 whole. Write that expression down. Pause the video if you need to. Where we need to start is what this whole is before we can answer what fraction is going to make it. So we need to think how many parts will make this whole. That leads us to look at that denominator. We know 6 parts, 6 equal parts will make that whole. I know if I wrote that as a fraction, 6 parts of 6 parts that make the whole would be 6/6. 6 divided by 6 equals 1. 6 times 1 equals 6. One group of 6 equals 6. One group of 6. Let's rewrite our expression. 2/6 plus what would equal 6/6. We know what about our denominators? They do never change. They never change. I know I need to work with 6 parts that make the whole. Sixths. 2 plus what will give me 6? 2 parts plus how many more parts will give me 6? 2 plus what will give me 6? Well, if I have 2 and I need to get to 6, I can count up. 2, count with me, 3, 4, 5, 6. That is 4 more. 2 plus 4 equals 6. Or, if I wanted to think about it, I could have subtracted 2 from 6 to get 4 when I'm finding unknowns. Different lesson. So, 2 parts plus 4 parts equals 6 parts. I know denominators don't change. That is the parts that make the whole. 2/6 plus 4/6 will make that whole. All right, young Padawans. If you made it through this lesson, the force is strong with you. Your you-do, it's in that Google form. I'm trying to help you learn fractions, understanding fractions and their value. By doing that, is that how? Is through the length model, area model, decomposition, and making a whole or zero into and using fractions. All sorts of problems will be posted with those strategies. Do that you do. Yearn to learn.